All right, today we are diving into something seriously cool. It's a new way of thinking about neurotechnology called Corral Neuroprosthetics. And trust me, it completely flips the script on how we could help the brain handle things like paralysis or phantom limb pain. But before we get into the nitty-gritty, I have a question for you, and I want you to really think about it. Is your brain hallucinating right now? Believe it or not, according to a whole lot of modern neuroscience, the answer is yes. And understanding why that is, well, that's the key that unlocks this entire amazing concept. So let's get into our first big idea, your brain's everyday hallucination. And just so we're clear, this isn't a bug, it's a feature. It's actually fundamental to how your brain works every single second. This idea is called controlled hallucination. And here's the deal. Your brain doesn't just sit back and passively absorb information from your senses. Nope, it's actually a hyperactive prediction machine. It's constantly generating its best guess about what's going to happen next. And our senses, what we see, hear, and feel, are just the fact checkers that tell the brain how to adjust its predictions. So what you get is this beautiful, constant feedback loop. Predict, act, sense, correct. Your brain predicts a coffee cup is hot. It acts by telling your hand to move, you sense the actual temperature, and you correct your model of the world. It's this seamless dance that lets us navigate reality so effortlessly. Which leads us to the core problem this research is trying to solve. What happens when that beautiful, essential loop breaks? This is where we get what the source material calls feedback catastrophes, and that is such a powerful term for it. Think about paralysis. The brain sends out a prediction and intention to move a leg, but because of an injury, the sensory feedback, it never comes back. That loop is shattered. The brain is basically just shouting into a void. And when that loop breaks, all those prediction errors just start piling up with nowhere to go. The brain's signals get no reply, and the whole system can just get trapped in these really frustrating, unstable, and sometimes painful states. Now, the traditional way we've tried to fix this is with brain-computer interfaces, or BCIs. The basic idea has always been to sort of eavesdrop on the brain, decode a specific signal, and translate it directly into a command like move cursor left. But here's the thing, that whole approach is a bit like trying to understand a deep conversation by only listening to one person shouting keywords. It's often fragile, it takes a ton of computing power, and crucially, it kind of ignores the brain's natural loop-based way of doing things. And this table just lays out the difference so clearly. Traditional BCIs are all about one thing, decoding accuracy, getting the command right. But Corral Neuroprosthetics, it changes the game completely. The goal isn't accuracy anymore, it's stability. It's about keeping the entire brain-body device system in a healthy, productive state of flow. Which brings us to the really elegant solution at the heart of this research, the idea of building a neural corral. So what in the world is a corral? Well, the best metaphor is a safe playground for the brain. The system creates a set of gentle boundaries that keeps the user's neural system in a productive sweet spot, a place where it isn't frozen and stuck, but it also isn't spiraling into chaos. It's a stable space where the brain can actually learn again. This is just a profound philosophical shift. We are moving away from trying to read someone's mind and pull out a specific command. Instead, the goal is to gently reshape the whole field of possibilities, to create a space where the user can discover workable strategies for themselves. And this totally reframes learning. The user is no longer just training a machine by doing some task over and over. They become an active explorer, mapping out the boundaries of this new space. And get this, failure isn't getting a command wrong. Failure is just getting stuck. The system becomes a partner in discovery, not a judge. Now, to manage this corral, we need a new language to describe what's happening inside. And this is where the really cool concept of transition motifs comes in. A transition motif is basically a recurring, measurable pattern. It's a way of describing the behavior of the whole combined system, the brain, the body, and the device, as it moves between different states. Think of them as the dynamic weather patterns of this new interaction. And I absolutely love the names the researchers gave these patterns. You've got the good, the bad, and the ugly. The good is a breathing hole. That's a smooth, stable, easy state of control. The bad is a persistent maze. You know that feeling, right? When you're stuck in a loop, trying harder and harder but getting nowhere. And then there's the ugly, a cascade collapse, a sudden, total loss of control.
So the job of the Corral system is to act like a gentle guide. It learns to recognize when the system is heading into a persistent maze, and it just provides a little nudge back towards a breathing hole. It's all about cultivating these helpful, healthy states.
And when you put all of this together, it points toward a much more humane and collaborative vision for neurotechnology. Let's just walk through how this might feel for someone with phantom limb pain. First, containment. The system puts gentle boundaries on the chaotic pain signal. The user might feel, okay, the pain has edges now. Then, unfolding. The user intends to move their phantom hand, and the system provides real feedback, maybe vibration. The user feels, wow, my intention actually landed somewhere. And finally, closure. The system guides the user to a stable, calm, resting state. It's about transforming the experience, not just trying to delete it. And this part is absolutely critical. The whole thing is built on ethics and co-design with the user. We're talking about users naming their own experiences, having the power to override the system at any time, owning their own data. Agency and transparency are baked right in from the start. Which brings us right back to the central takeaway. The goal is stability, not accuracy. It's a huge, profound shift from demanding the brain get the right answer to instead creating a stable environment where the brain can find its own answers. So I'll just leave you with this final thought to chew on. What if the future of assistive technology isn't about building better decoders that turn thoughts into commands, but about building better corrals that turn struggle into possibility? Thanks for digging into this with us.